Okay, now we'll be discussing about the membrane bioreactor. So all you have to do is go to the dashboard and just click biological and just click MBR. So all you have to do is just, okay, we'll just click example and calculate for now. So this is the process flow. So we have an anoxic tank, we had an aerobic tank, and then we have an MBR tank. So you need to input the parameters here. So once you're done with that, so just make sure that you understand that this is for one train only. So if you want several trains, just place it here, how many trains you have, and then it will calculate for you the total. So if you have 3 duty, and then your total flow rate will be around 68,100. If your per train flow rate is around 22,700. This is just for standby, you don't count this one. Okay, so just give you a guide here. So this is the steps. You don't really have to, once you master this, you don't really have to like memorize each step. So all you really need is to know the flux. Get this from the supplier for the MBR flux, and then you'll then need to find the volume of the MBR tank by knowing the volume of MBR tank to the ratio of the membranes. So you can also get that from your supplier. You set your MLSS for the MBR, which is higher than the aeration tank. So there's 2 aeration tanks, okay, or the 2 tanks that are aerated. One is the normal activated sludge aeration tank, and the other one is the MBR, or the membrane bioreactor. So both have biological degradation through the oxidation of BOD. Okay, so it's just one big aeration tank. So for now, let's call the aeration tank or aerobic tank the one with the one that does not have an MBR. Okay. So yeah, so this is the aerobic tank volume. So this is the activated slash aerobic tank, not the MBR tank. Okay, so once you set this one, you'll know the aerobic tank volume, and then you will have the nitrate that comes out of the aerobic tank. And then, but some of you don't all of this, not all of this will of the nitrate will go out, so you have to return them. So there's a return activated sludge system. So okay, this process here, 6, 7, 8, 9, and 10, this is actually an iteration process to know if your denitrification rate is enough, or your nitrate removal. Okay, so what happens is that you'll need to know the tank size. The bigger the anoxic tank, the greater the nitrate removal. And then so you figure out the food to mass ratio, and then the specific denitrification rate, and the removal. So you don't really need to do this step by step. All you really need to do is just input as a percentage of anoxic tank, and then you just check. Okay, so anyway, so if you do it manually, like manual calculation, what you do is once you know the aerobic tank, you know the ammonia removal, you put an initial value of your anoxic tank, and then you determine the food to mass ratio, you determine the specific denitrification rate and corrected specific denitrification rate, and then you'll figure out your nitrate removal. And then if your nitrate removal is smaller than the nitrate going into the reactor, you do the whole calculation again. Okay, that's how you do it manually. But here it gives you an instant feedback if you set a certain volume of your anoxic tank, and then you'll figure out if it's enough. So I'll show you later on, and then you'll figure out. Okay, once you're done with this, you just know the optimize your aeration. So you will determine how much air based on the efficiencies. You can determine how much the size of the blower is, and then you'll do the alkalinity balance. So you already know what air is required. So, and then you will need to know the alkalinity. So when ammonia is converted to nitrate, it consumes alkalinity, so you need to dose that. And this is anoxic zone mixing. So after you figure out your anoxic tank volume, you will need to know how much power of mixing you need. Okay, let's just go back here. So just click example. So yeah, so once you've done with this, set up your influent, total hydraulic loading and effluent requirements. So let's go to step 1 here. You go to the MBR tank, just set up your flux, MLSS. You'll find out your aerobic tank. And then also your reflux ratio here. So let's just put this constant, but if you want to increase the amount of denitrification, you need to increase this one. So this is already at maximum. Let's see if we reduce this to, so for now it's 6, and then the amount of nitrate going to the anoxics is around 562,000. So we'll just convert this to 4. Let's just check it. Okay, so it decreased. Okay, so for now let's just go back to 6. Okay, 6 is very high number, so just maybe between 4 to 6. All right, so anyway, the most important thing is that this removal here should be higher than this one. Okay, this NOx removal should be higher than the NOx feed to the anoxic. If it's higher, then it's no problem. So if it's lower, so what you can do is, one thing you can do is just increase this one. So it's 568. So let's increase the tank volume to aerobic volume percentage. So it increased. So let's revert it back to 20%. Right? So once you figure that out, the next is so yeah, again, this is your reflux ratio. This is the combined your internal recycle and your return activated sludge. Okay, and then this is your efficiency. So and then this is your total air requirement. And then if you want to optimize it, just change it here. All right, and then this is your alkalinity sizing. So or dosing, you just need to know how much alkalinity you need to add. And this is your aeration tank. So this is both the aerobic and the MBR tank. So you find a way, like this is your volume of your aerobic tank and your MBR tank. So that's around 3,600. So you just find a way to reach that value. Okay, so let's say it's 20. Maybe 30. This is 32. So anyway, you just figure out how to get this value here. Just play around with these numbers here, and then once you're done with that, just click generate report, and then it looks like this. So you just click print report here, and then you just input your membrane brand and membrane model, and that's it. Thank you very much.